Welcome to this session on data science and some of the tools that statisticians need to be data scientists, if that's an aspiration. The way the structure is going to work in this session is I'm going to quickly introduce the session, and then we're going to have talks from Matt Upson and Amy, and then I'm going to speak at the end. So we're going to kind of top and tail it, if you like. So really what this session is all about is some of the skills that are being requested by employers, some of the skills that seem to be making up this data science thing at the moment. So just to start off then, I thought I would, I'm a statistician by training, so I always use this slide. Has everyone heard of Professor Jeff Wu before? Quick show of hands. Okay, so we can basically attribute the term data science to this guy. Professor Jeff Wu in 1997 was doing a presentation in the US, and he is a statistician, and he stood up and said, you know, statistician is a bit of a difficult term. I'm never quite liked the term, what we should be as scientists, but we use data. So this guy stood up and said, I think data science is a much better term for what statisticians do. Okay? So what it originally meant, where it came from, what it's usually attributed, is just basically a way of saying statistician, but using a slightly different phrasing. So whenever I'm talking about data scientists from maybe from a non-stats background, I kind of like to mention that actually this is kind of our term. They love that. But that's basically where it's come from. But what it's come to mean is almost more important right now. It's actually come to mean something slightly different. Now, if you go on to Twitter, you'll find lots of different meanings. These are some of my favorite tweets. Hope you've seen some of these before. So a data scientist, a statistician, lives in San Francisco. This is Corey Chivers. It's a really good data scientist is a mechanism for turning coffee into and data into better decisions. That's great. And Big Data Borat says data science is stats on a Mac. And there's kind of a bit of truth in amongst all of that, right? That's kind of where it comes from. But when you start looking at what a data scientist is and what skills they have, what you start to see is you see a coming together of a number of different disciplines. Okay, so this is Josh Wills, and he's probably one of the first people who came out and gave a relatively sensible definition of what a data scientist is. And he said that it's a person who's better at stats than a software engineer and better at software engineering than a statistician. So you're kind of starting to see this idea that it's kind of an amalgamation of a few things. And that carries on. In fact, data scientists, when they talk about data science generally, love Venn diagrams. You can't do a data science talk without a Venn diagram. That's rule number one, right? You can't do that. If you're going to do a talk on data science, Venn diagrams are a must. But this is kind of one of the famous ones. This is Drew Conway, and he talked about data science being a meeting of sort of business and domain knowledge and experience with hacking skill, with analytic knowledge. And that's kind of where data science comes from. And if you look across all the different definitions of data science these days, what you'll find if you boil it all down is you find this diagram, right? You find someone who can do the analytics stuff, someone who can write code really well, and then someone who has this kind of like business experience or a bit more of a head-up kind of communication. And that's typically the Venn diagram that's used, okay? So the way this session is going to run is we're going to take these three bubbles. We're going to break them apart. I'm just going to do that again because it took me half an hour. There we go. The session, that's kind of the peak for me in this session, so you can leave me know. What we're going to do is split these apart and have three different talks. Amy from Mango Solutions is going to talk about machine learning. Amy himself are both statisticians, so what does machine learning mean to us? And what do we need to know? And is it the same? And so on. Then we're going to have Matt Upson from GDS. He's going to talk about the coding style of things. So, you know, I write code every day. Does that mean I'm a coder, a programmer? What does that mean? And then I'm going to come back at the end and do more of the third bubble, that business piece. Okay? So that's the way the session is going to run. And so the first thing is to invite Amy up, and she's going to talk about machine learning.
Okay, hopefully that microphone will pick up. Okay, so as Rich says, I'm going to talk today about more of the analytic piece of where data science fits for statisticians. And when Rich asked me to give this talk and he gave me this title, I was kind of terrified to stand in front of a room full of statisticians and tell them why we should all be doing machine learning and what that means. Actually, in writing this talk, I think I've actually got the easy job today, because actually I hope what I'm going to tell you is that actually you don't really need me to be stood here to tell you this. This is all things that we already know. So just before I get started, I wanted to tell you a little bit about me, why I'm kind of standing here today. So my background, as Rich says, I'm a statistician. I studied statistics at Lancaster. I basically did every statistics course I could possibly take at Lancaster. I was really in love with stats. But I really wanted to actually do something with data, and I guess for me that's where data science really fits. It's not just learning statistics, it's actually doing something with data. So I joined Manga about 5 years ago now. Rich will tell you all about how I really don't like being called a data scientist, and I don't like to use the term. I've kind of grown to use it a bit more now, because I think it is quite a good description of what we do. But hopefully you'll see what I've kind of learnt whilst I've been at Manga of what data science is, and machine learning in particular. So roughly what I'm going to talk about, I'm just going to talk about, first of all, what is machine learning, because I think there's a lot of sort of a grey area there around what it actually is and what it means. The important piece then for me is the language of machine learning. I'll come back to why I think that's really important, and finally touch on just some of the range of machine learning models that we might need to know as statisticians. So to start with, when I started writing this talk, I thought the first thing I have to tell you is what really is machine learning. And it was really challenging for me to start to distinguish between what was machine learning and what was statistics. And the best description I could come up with what machine learning was actually learning from data. So taking data that we currently have, learning from that to start to predict the future and start to look at what might happen next. But when I started to think about that, I was like, well, what really is statistics? Because surely that's what I've been doing all the time. And I actually then started to think that, well, actually maybe statistics in the traditional sense of statistics is actually looking at the data and explaining why something happens. So whereas machine learning, we tend to focus more on predicting what's going to happen in the future, statistics, we're sort of more thinking about why did this happen, what drove these processes, and that more descriptive side. But essentially what I boiled this down to, and where I feel these two terms are kind of grey and uncertain, is that actually we kind of abuse machine learning and statistics a little bit as terms. So machine learning, we will talk about it being predictive, but actually machine learning is really the algorithms underneath. So I'm going to continue to abuse the terms a little bit this morning, but that's where I got to anyway. I couldn't talk about machine learning without talking about some of the uses of machine learning and how we see it actually in our day-to-day lives. I actually love the fact that machine learning is in pretty much everything we do now, because I can finally talk to my family about what I do, and my grandparents can even understand what I do now. Of course, we've all seen the Google example, so did you really mean? I would recommend Googling did you really mean, because there's some really cool examples of this that were massively inappropriate to put in a talk, but there's some really funny examples. I thought this was the most tame of them. But we all know now that how Google is using machine learning to actually try and correct us when we typically make a typo, but there's some funny ones of those as well. Recommender systems is also a really good example. I'll let you try and guess what I might have been buying recently, but Amazon trying to predict what you're going to buy next, Netflix trying to predict the next film you might want to use. These are all examples of machine learning. There's also, of course, the fraud detection, when your bank really unhelpfully blocks your card because it thinks that you've been doing something fraudulent. These are all really nice examples of how machine learning is actually being used in our day-to-day lives. So after I thought about that and how we're using machine learning, it kind of got me to think, well, okay, in the context of that, what is machine learning? What is it more than what I've already said? And I kind of boiled it down to these three things. So it's actually using our data to identify patterns. So trying to pick out what it is that is common among the data to result in the actions that we're seeing. Then using that to predict those new events. And finally, the most important piece for me is this last bit, learning from those new events to update our model and update our predictions for the future. So Amazon's recommender systems would be no good if it continually recommended based on its very first customers. It has to keep learning from that and updating. And that, for me, was the most important piece. So the question I guess I need to answer straight away is machine learning actually something different? I work in a very varied team, and I think half of my team would probably tell me yes, machine learning is totally different. It's not statistics at all. As a statistician, I would say no, it's not. I think the reality is it's kind of somewhere in between there. So there are things that, as statisticians, we need to learn. But actually, we're already in a good position to use machine learning confidently and very competently. The biggest challenge I think we all face when we come to machine learning is understanding the language. A lot of machine learning techniques have come from computer science. They've come from people who don't already have the language of statistics. So the biggest hurdle for me when I'm working with people who use machine learning all the time is actually speaking the same language as them. So they'll talk about things like targets and features and supervised and unsupervised learning and bagging and boosting. And when I started working with them, I was like, geez, they're talking a language I just can't understand. And then I started to realize these were all things that we all know about. So target, we all know the term response variable, right? That's all that a target is. Features, they're your predictive variables. So nothing that's unusual to us. The learning I'll come back to in a moment, but bagging and boosting, again, terms that are kind of alien to us. Bagging is basically Monte Carlo methods. Boosting is just kind of improving your models based on previous fits. So all things that as statisticians we're really, really familiar with. And there's just essentially that translation that we need to do between the two languages. So for me, this is the biggest challenge is actually learning that language. Okay, in terms of the models themselves, they're kind of broken down in machine learning, but again, there's not a huge amount that we need to worry about when it comes to machine learning models. They're broken down, so the first thing that you'll hear people talking about is supervised learning. Supervised learning essentially means a model where you already have the outcome in your data. So that's pretty much everything we do in statistics. We fit a model based on data where we already know the historic outcome. If you're thinking about survival analysis, for instance, you already know whether a patient died or not when you're fitting that model. So that would come under this category as supervised learning. So machine learning models that we talk about, regression. I hope that's not something that's scary to any of you in this room, but that's a supervised learning technique. Decision trees, again, I'm sure a lot of you will be familiar with decision trees and you will have come at that from a statistical approach. But just simply that idea of building that decision tree, that is considered as a supervised learning model. Neural networks was one that, for me, was something a little bit new, just because I hadn't done that from a statistical perspective before. Essentially, there's a couple of different variants of this. You might have also heard of it as deep learning. It's what is being used for a lot of the handwriting recognition. Some really, really cool stuff that's going on. But essentially, neural networks, if you're not familiar, boil down to regression models. But we're just simply putting in extra layers to kind of account for behaviors that we can't observe in the data. So statistically for us, it's actually something quite straightforward, but it's given a almost scary name that we might think, oh, I don't want to touch that. Support vector machines, again, another one that is kind of thrown about in terms of machine learning. Essentially, and I'm kind of reducing this down to a very simplified term, it's kind of clustering in multiple dimensions. So again, a lot of you will be familiar with clustering, and that's just a straightforward extension of that. So hopefully what you can see from this, whilst the term is used as supervised learning, that as statisticians, there's nothing here that is really new to us. These are all things that we can be familiar with. And whilst it might be techniques we're not using every day, we do already have that toolkit to be able to understand these. The other type of learning that is talked about in machine learning is unsupervised learning. And these are essentially problems where you don't know the outcome. And I think the most familiar one to most statisticians will be the second that I've put here. So things like principal component analysis. So where you're essentially trying to reduce your dimensions of your data. That in machine learning is considered to be an unsupervised learning problem. Clustering as well. Clustering actually kind of fits into both supervised and unsupervised, but typically we talk about it as an unsupervised learning problem. So again, as statisticians, there is nothing that you might not have used all of these techniques a lot yourselves, but we're kind of familiar with these things and we don't have to learn anything really that new here. Ensemble methods is one that I find that people who do machine learning a lot like to throw in to try and confuse you a little bit. This is where they like to think they're like ahead of statisticians. Ensemble methods is again something that we do as statisticians all the time. It's combining approaches to get the best result. So where you might, I tried to think of an example, use regression modeling to take the trend out of your data before you go on to fit something else. That's kind of what we're doing with ensemble methods in other situations. So random forests is one of the most widely used. Essentially that's your decision trees, but fitted lots of times. So again, this is where that term bagging comes in. So it's your Monte Carlo estimates on your decision trees there. Gradient boosting is another example. So gradient boosting, we're simply taking our previous model fit and each time trying to improve the weakest area of the model. So again, nothing that as statisticians is really that new to us, but these are all techniques that machine learners will use quite regularly. So I think what kind of comes out when you look at all these models, the thing that really comes out a lot is that there's so many of them. And people who work in machine learning will kind of just throw things at all of these different models, not haphazardly, but they'll kind of use all of these models quite regularly. And what kind of stands out to us at Mango is that as statisticians, we often focus on one model. If you think about the traditional statistician's job, you will actually focus on maybe fitting survival analysis or mixed effects models. Rich will, I'm sure, tell you all about his job in the pharma industry where he just did the same model over and over again. And that's how, as a statistician, we tend to work. As data scientists, we have to be a bit more familiar with everything. So there's less focus on the deep dive into one technique and more focus on being familiar with lots of different options that you can fit. So really that's the key difference for me between statistics and machine learning, is that we have to be more broadly familiar with the techniques available to us. I couldn't do this talk and not talk about a few of the other things that machine learners, I'm using machine learners, it's kind of a strange term, but they'll use a lot and try to make you believe is completely new to machine learning. One of those things is the idea of test and train data. This was something I remember doing in like my master's degree and not even thinking about. And apparently in machine learning, it's a huge big deal. And they've invented this great thing of taking out some test data and using some data to train and some data to test. But again, that's an idea that's really familiar to all of us, and I'm sure you're doing all the time. Cross-validation is the same. They'll tell you all about how great cross-validation is, but I'm sure most of you, again, are doing that on a regular basis. The last one I think that they've tried to invent is feature engineering. And feature engineering is a really funny one because they've changed all the terms to be kind of crazy terms. These two are a couple of my favorite confusing terms. One-hot encoding, I have no idea why it has this name, but essentially this is creating dummy variables from your data. We've all been doing that since like day one of statistics, but it's got this crazy name now and we all have to know that it's one-hot encoding. Discretization, this is essentially creating bins from your data, so binning up your data into different groups. And again, they're all things that we're probably doing every single day. So what do you need to know? Well, hopefully I've pointed out that you don't actually need to learn too much new stuff. It's all things that we've been doing since we started out learning statistics. So for me, machine learning is not new. It's not something to be afraid of. We just need to learn the language so that we can talk to people who are coming at it from a different background. And the important thing is to remember that you have to take that broad overview. You can't just learn one type of modelling. We have to understand quite a different range of techniques. The last thing, if you do want to learn more about implementing machine learning, the RSS are running a course in October. I don't know what the exact date of it, but it is towards the end of October, and I'm sure there's lots of information from the RSS that you can get there.
My name's Matthew Upson. I'm a data scientist at the Government Digital Service, and I think, as Amy sort of intimated, I feel like I've got the stickier end of this bargain in that I'm going to tell you a load of ways that it's probably a little bit, that data science is maybe a little bit different to what you're doing. Shut me down if I'm wrong, but let's go. So first of all, what is the Government Digital Service? I feel like many of you probably have never heard of us before, and that's fine, so I should probably say a little bit about what we do. And basically, we are a government body that sits inside the Cabinet Office, and our official goal is to make it easy for government to be digital. And a lot of the time that means that we build some of the critical infrastructure that sits underneath services which you would access normally through gov.uk as a citizen. So that might be things like you need to pay money to government, or government needs to pay money to you, or we need to send you a text message to say that your passport's on the way, or you need to verify your identity before you access a government service. That's the kind of stuff that we're building, and we make that available to other parts of government so they can then build their services based on our services, and it all drives efficiencies and all that kind of stuff. There's more you can read about it on this blog, so if you are interested, please do read about it. The interesting thing about this is that basically everything we do relies on data in some way or another. Like all our services will require data to be processed. And that's why we have data scientists in GDS. So I sit within a team called the Better Use of Data team. We have two remits. Number one is we do data science. We produce data science products for our stakeholders across government and in GDS. And the other thing we do is to build capability across government to try and get to a point where there is this bank of data science skills in every single department, and we are making use of data science techniques as a government. So the name of my talk, rather arrogantly, is the other things a data scientist needs to know, and I would caveat that by saying some of the other things that you need to know, and this is really driven by my experience of working in GDS. So there may be people who have a much stronger private sector experience who might want to argue with me, and I'm happy to have that argument after the session, but please wait till the end. So one thing I'm definitely not going to talk about is this. Many people will have had this discussion before. There are 40 million articles on why Python is better than R or vice versa. So I'm not talking about that at all, but we all know Python's better. And what I'm really talking about can basically be digested down into this term data ops. Now, this is one of those horrible terms that Amy's sort of been disambiguating over her last presentation. I'm not actually going to try and disambiguate this. There is a website you can go to that describes a number of principles which go towards this term data ops. But actually what I'm going to do is spend the rest of my presentation giving you examples of data ops approaches. And I hope by the end of the presentation you'll have a sense of what data ops is. I'm trying to make this a hashtag for 2018 now. I tried to do it for 2017, it didn't really work. So if you are tweeting, please use the hashtag DataOps. So in these principles that you'll find at the DataOps manifesto, there's something like 12 principles around data ops. And one of them is, probably the most important one, is that it's a team sport. And I've changed it slightly. So data science is a team sport, and I'm definitely not the first person to say this. So DJ Patil, who was the US government chief data scientist before Trump, he said this, and it's not just a truism, it totally is true. And there has been this kind of anti-pattern in industry and in large organizations, particularly including government, that said, oh, you can just get one data scientist in and they'll do some amazing stuff. And normally that's where things go wrong. because it's very, very difficult to be one lone data scientist sitting inside a large organization trying to turn around an organization's data and bring data science and make it a thing. So you usually need a team of people. And I'm going to sort of expand this out a little bit to say, throw a bit of a straw man up there, and that is that data scientists often work in mixed agile teams to deliver projects. And there are 3 subscripts here because it kind of has 3 implications. And this is where I start about talking about the kind of things that might be useful for you to learn about if you were wanting to take that transition into data science roles. So the first thing is, what is Agile? Well, Agile is it's a way of working. It's basically a project management process which identifies short cycles to deliver value very quickly over longer term projects which are much more traditional in large organizations. I'm not going to say too much about that. There's probably more than 40 million articles around this online. So if you want to read about Agile, there's lots of things you can read about it online. But just to say that we often work in Agile teams as data scientists, and what that means is, for us at GDS, that we kind of work in this cycle. And that means that we start with user needs. So for us, that means we would ask citizens like yourselves, what do you need from a government service? And then we'll do a bit of a discovery to work out how we can deliver something to solve those user needs. And then we do like a first stage, which we call an alpha, which is where we deliver what's sometimes called a minimum viable product. So that's a thing that actually works. And I'll come back to this idea of things, but it's not just ad hoc analysis a lot of the time. It's usually a thing. And then we will test that, and it's usually tested internally. And then we will iterate on top of that and go to a next phase called beta, and that's normally tested externally. And then finally, we'll go through to this kind of live process. And that's how we do it at GDS. Lots of other organizations have a different flavor to it, but the idea is that it's delivering value early and then iterating on top of it. And that has an impact on how you have to work as a data scientist. So the other thing is that you're working in a team, and agile teams don't just consist of data scientists. They consist of a whole range of other job roles which you've never heard of, like this. So this is what my team looks like. There are 6 data scientists and 2 software developers, and that's kind of the technical side of it. We deliver the actual products, or most of the products. We also have content designers, user researchers, delivery managers, product managers, policy analysts. Now, this is probably the most extreme case I don't want to say the most extreme case in the UK, but it may be. And that's partly because we have a dual remit in my team. We're trying to build capability, and we also sit with an organization that has user needs, so the needs of citizens, recognized as a very important thing. So you may not see user researchers in private sector companies so much. You may not also see content designers in private sector companies so much, and you may see some of these other roles changed into business analyst or whatever it happens to be. The key takeaway here is that I spend a lot of time explaining what we need to do and what we are doing and what we have done to people who don't really understand it. And so a really, really key skill for any successful data scientist is being able to distill technical topics down to simple concepts that anyone can understand very easily. And this is in a team context. That whole thing is even more important when you start talking to your clients. So communication skills are really, really important. And something that a colleague of mine has brought up before is actually the idea that empathy is important. So being empathic about the other people in your team and the other people you're delivering stuff to, and understanding what it is that they understand, and trying to broach that gap so you're all basically talking the same language. And just to touch on, I think I've touched on this slightly before, so the idea of delivering projects, well, we often don't use the word project, we often use the word product. And as a statistician, or certainly in my experience in research, I was often delivering reports and ad hoc analysis, or even figures or models. So it's less of that. Well, certainly in my team, it's less of that. It's more a product. So I might produce a data science model or a machine learning model, whatever, that sits inside a much, much larger product. And in fact, when you look at actually what my team as a whole does when it delivers data science, the data science bit is actually can be quite small. You spend quite a lot of time when we go to our customers, and our customers are normally other government departments, we spend a long time trying to work out what their problem actually is, and what we can then do about it. And then there's this magical bit in the middle where unicorns are flying and this great stuff happens. And that might be 20%. It might only be 10%. It could be a really small bit. And then we're back into this other sort of phase where we're then selling it back to the business and explaining what we've done and how they can use it and taking it forward like that. So I guess the key takeaway from this is, again, it all comes down to communication skills. So if you can't do this, and it's not all going to fall to data scientists, we have these other job roles to do this kind of bit at the beginning, but you will need to be able to interact with people in a way that is really engaging and simple, so you can get your ideas across. So how am I doing for time? Okay. So data science as a team sport is one of those principles. In fact, it's a team sport is one of those principles from the DataOps Manifesto. These are two more principles. Analytics is code and make it reproducible. And I'm going to sort of combine these two together and give you an example of a product or a project, maybe, that we did recently for another government department, which kind of enshrines how we take these two principles and put them into a product. And I guess the idea really behind these two principles is this, that the final thing you produce is not really the important thing. The code is the important thing. And why is that important? Well, because actually, okay, in the end, your client might be using the figure, the report, whatever it is you've produced for them. But actually far more important is when they come to you the next time and they say, hey, can you do it again? And can you change it slightly? Or can you make it bigger? Or another customer comes along and says, can you do the same thing for us? It's having the ability to go, oh yeah, that's easy. Because we made this whole process in code, and we can just basically spin the same thing up for you without having to go through messy manual processes to get to the same endpoint. I'm going to talk through this in more detail. So this project or product I was talking about is basically all around this publication. So as you'll know, government produces a lot of statistics. We don't actually know how many statistics we produce. When I say statistics here, I mean statistical publications. So we produce a lot. And this is one publication produced by the Department for Culture, Media and Sport. And they produce this once a year, and it basically gives you statistics around how well certain sectors of the economy, which are the responsibility of the Department for Culture, Media and Sport, are doing. And they produce this year on, year out, and it changes relatively little each year. There's normally a few bits that come in and a few bits that go out, but it doesn't change that much. And this isn't a sexy data science project. I'm not talking about deep learning here. I'm not talking about any really interesting machine learning skills. We're really talking about, and the most complicated things we're talking about here is sums and means. It's very, very simple stuff, but it's actually really important because people will then take these statistics and go and start making political decisions based on this kind of stuff. So it's important that we get it right. So even though I'm not really talking about a sexy data science thing, all of the principles that I'm talking about are relevant to every other bit of data science work that we ever do. So when I first came to this publication, and I should say, if you go there, you'll find that there is a PDF. If I'd scrolled down a little bit more, you could download the PDF. And that is the thing. For the team at the time when we first came to it, that was the thing that they had their mind on. We're going to produce this publication, we're going to do it this year, and we're going to do it the year after. And the code definitely wasn't the thing. So this is how we kind of changed their mind. So this is kind of the process that they used to get to, or used to use to get to this PDF thing, which would get published on gov.uk. They would start by extracting some data out from a data store, whether that was an Excel spreadsheet or a SQL database. They would do some manipulation in a proprietary statistical bit of software. They might then extract the outputs of whatever they've done into a bit of spreadsheet software, and they would make the tables look nice, and then they'll probably copy and paste that into a Word document, and then from there they would convert it into PDF, and then finally it wings its way onto gov.uk. So there's a lot of steps there, and there's a lot of arrows, and often those arrows are not programmatic, they're manual steps, where you copy and paste from one thing into the next, into the next, into the next. And in fact, it's actually slightly more complicated than that because it's never done by one person. And this is actually quite a short publication. Some of them are much, much longer. And it might be done by 5 people at the same time. So all of this copying and pasting is happening in parallel with different people. So again, you're getting more propensity for manual transcription errors as people are copying tables and whatnot across. And of course, we're really worried about getting the quality right. And so there is this kind of other step, which is around checking that the numbers are right. And that, because the quality of these publications has got to be right. So how do you actually ensure that quality? Well, essentially, you just do the whole thing again. Someone else will do it again. And then you would compare the two and make sure they match. So it's a huge amount of work, and there's a huge amount of manual steps. And the propensity for making errors is quite high. So we applied some data ops principles, and we managed to fix this process in such a way that we could reduce the amount of time it takes to produce that publication by 75%. And we also created a clear audit trail. So at any point, you could go back and you could see exactly who did what, why they did it, and I'll talk more about that. So the next few slides, really, I'm just talking about how we actually got to that place. So the first thing we did was basically we remove all manual manipulation of the data, right? So you get your data set in raw form from wherever it comes from. And there's always a temptation at this stage to go, oh, well, I don't really need that column. Or the name of that column doesn't really match with how it's going to match in the final publication, so I'll just change that. And the problem with this is that you can change it in a spreadsheet, but it will never actually get recorded if you do that. So by making this kind of, having this amnesty where we said, right, okay, tell us all your manual manipulation steps, let's get rid of them. You can get rid of all that difficulty and that stickiness very early on. So, and this is kind of a theme through the whole project, really, is that you're trying to remove all these manual steps as far as possible. And then the next thing we go on to is basically version control. And if you take one thing away from my talk, this should definitely be it. Version control is a thing, and it works very well. And it's software developers have been dealing with code for 50 years. They've developed all sorts of mechanisms for dealing with their code and making sure it works really well, and we should definitely steal them at every single opportunity. And the first thing we can steal is version control. So this is not what I mean by version control, and I'm sure we're guilty of this in many ways. I actually had to mock up this folder, which I was quite proud about. It didn't exist on my machine. So this is not what I mean by version control. Manual version control systems, it's a lofty ideal. In my experience, it never works because I can never be bothered to fill in the manual table. What I'm really talking about is this. So I don't want to bore you with the technical details too much, but this is basically, these two tools we're using here are Git and GitHub. Google it, there's loads of information about it. But essentially, I've got a pointer, great. So essentially what you see here is a checkpoint for a particular bit of work that I've done. And you can see there's a picture of me looking cool in pink shades. And one of my colleagues here who's a software developer. So this is talking about how we collaborate together with software developers. So we use, with software developers. So we use these tools. And this is all, in this particular case, this is all publicly available online. In many cases, it might not be because of the sensitivity of the project, but you could literally go to this website and you can track back from the 8th of August right the way back to the start of this project, and you can see every single change that we've made. And there's a number here which we call a hash, and that hash basically is a unique identifier for every single change that's made in the document. So at any point, if we decide, okay, well, that change you made last Thursday wasn't a very good one, let's go back to how it was on Wednesday, we can just do that. We can just roll back and say, okay, let's go to this one and start from there. And we can scrub that one off, or there's incredible flexibility about your work pattern. So this is it. This is GitHub in use. It's really, really good. Check it out. Google it. There's loads of stuff. The second thing really is that we moved away from this idea of writing scripts. So I didn't train as a software developer, and basically the way I learned to program was by writing a long list of instructions, and my computer would just chunk through one instruction after the other, and at the end of the script it would sort of finish. And that's great when you're learning, but it's actually not the way that software developers write software. In fact, we can learn lessons from those guys and start to write software in a much more sensible way. And what this really boils down to is getting a deeper understanding of the language that you're working with, whether it's R or Python or whatever. And you start to learn about scary concepts like classes and methods. And again, I'm not going to talk in too much detail about that because it's quite technical and boring, but there's lots of information on the internet. A very good place to start is this. So some of you may have heard of Hadley Wickham. He's a developer in the R world. He's written this book, which is free, called R for Data Science, and there is a very good section that explains why it makes a good sense to move away from this long list of instructions model to a more repeatable model. And he starts really by talking about functions, but eventually he'll start talking about packages and other stuff like that. And really, what we're trying to aim at is this principle in software engineering called DRY, do not repeat yourself. So if you find yourself copying and pasting large parts of your code and then changing small chunks of it to make it repeat something that you've done before, you're probably doing something wrong. There's normally a way to make that much simpler, much more robust. And the one thing we really want to avoid is taking all these clunky manual processes, these points and clicks from spreadsheets, and then reproducing them in code. That's that's the worst possible scenario. And when I started to talk about packages, so this publication that we actually produced an R package called EU Sectors. Again, I'm very pleased to see that if you Google EU Sectors, it's the first thing that comes up. And this basically provides a combination of these 4 things together. So all the functions, all of the logic, all of our operations that we do in recreating that publication all go into these functions. We can then write tests, which I'll talk about momentarily. But it also puts together the documentation and some relevant data, maybe not all of it, all together in one place. And this actually is really useful because it means that when I have a new member of staff come into my team and they say, okay, so let's get started on this project, how do I do it? Well, I just say, okay, just download that package, you've got all the documentation you need, all the data's there, get going. It's not a case of me going, okay, right, here's a folder, and in this folder, these are all the files that we use, and these are all my linked spreadsheets. It gets rid of all of that. It's all just in one place. You can pull it down off GitHub with one single console command in R, poof, job done. And so this testing thing, so software developers are very, very worried about testing, and we should be too. And particularly in government, we should be worried about this, because we need to make sure that these numbers are right. So once we move to a situation where we no longer have these long scripts of instructions that repeat every single, or have every single thing that we want to do, and we move to a situation where we might write more generic code that can be reused, we can write generic tests. And those generic tests can ensure that our code is doing exactly what we want it to. And in fact, there are 3 kinds of tests that we tend to use. So first of all, we use data integrity tests. So when we pull the data into our product for the first time, there's always some sort of check that will say, are all the things we think that it should be in the data? Does it roughly look like it should look? And that's all automated. There's no manual eyeballing of it. It just comes in, some checks will be run, and it will spit out a kind of report at the end to say whether or not it's happy with the data. Then we have what are called unit tests. So unit tests are where you've written your functions that might produce a model or produce a table or whatever. You write a function, or a test, sorry, which tests the exact output of that function. And you can look at all the edge cases and think about all the ways that your function could go wrong, and you can write tests for all of those. So this is where you need to work with the subject matter expertise of the people who do this for a day job and say to them, well, okay, what are the ways you know this will go wrong? And then you enshrine that all into the code. And then we can go a bit further and we can do what's called an end-to-end test or some other functional test, and that's a test of everything all together. So all of our individual functions which are unit tested, we combine them all together and we make this long functional test, and we see if we put some dummy data in at the beginning, do we get the right outputs right at the end? And I don't want to do that. I find that really boring. So I get someone else to do it for me. And it turns out that there are cloud services which will do this for me. So you can link this with GitHub, which is what we were using before. This is a service called Travis. And the key thing to take away from here is this number here. And that basically means that this test has been run 703 times. So it basically elevates your quality assurance to a level which is just simply not possible with people. We couldn't do it. We couldn't get people to check this 703 times. And all I need to do is push my latest change to GitHub, bang, it gets picked up, it'll run a test on it, and it checks that everything still works. And in fact, we go one step further than that. We actually want to know, is there anything that we're missing in our tests? Should we be testing more stuff? And it turns out that there are services for that too. So you can actually use a service like this. It's not a particularly interesting screenshot, but there's a service out there called CodeCov, which will look at all of the files in your GitHub repository. It will pick them up and it will compare it to your tests. And it will say, okay, of this file, of this code that you've written, how much of it is actually tested? And you can see I'm doing well here. Some of these are 100%. A few of them are only 92%. Actually, 90% is pretty good. If you're getting down to 50, 60%, then you might start to think, right, we need to have a look again at the tests we're writing because we're not covering critical stuff that we should be covering. And again, that's all automated. I don't have to worry about that myself. I just get an easy report at the end of every single change I made. And finally, I'm only going to have a quick slide on this. I haven't got any images. But one thing you can do for this particular product, which is a publication, we can combine the narrative of the publication with the code itself, so that we are not having two separate things, like a Word document and all of our analysis which needs to go into it. We can actually combine those two things into one, and that can be version controlled in the same way that we version control everything else. And for R, it might be using a language called R Markdown. In Python, you might use what are called IPython notebooks, and there's a whole range of other stuff that can be used for this kind of thing. Oh, and my numbering's wrong there, but there we are. So the final thing is that you should share what you've learned. So this is one of the other data ops things. We've done all this learning. We've come up with some good ideas. We've found some solutions to this kind of stuff. We don't want anyone else to have to reproduce what we've done. So we share it, and we share it really widely. So this is you can see I've had a busy day with lots of stuff open, but this is a URL you can go to right now. This is an R package that you can download with a single command onto your machine, and you can see all of the code that we've written, all of the process that we've gone through. And this is fantastic within an organization because we can say, just go to that page, you can see exactly what we've done, and it's fantastic across government organizations and different nations' governments. So I have a conversation with Scottish government today about this, and they can just look at it and go, yep, that makes sense, download it and use it. So it's all about taking all that learning and making it available as widely as possible within the constraints of whatever it is you've built. So just wrapping up, I'm completely unoriginal. There is a really, really nice podcast from these guys. I think it's actually even called All the Other Stuff, and it's another data scientist perspective on some of the other stuff that they needed to learn moving across from a more traditional academic background into a data science role. The other thing is that if you want to read about the process I've just talked about in terms of moving a more manual process into a more data opsy process, I have a blog post about it, and that's on gov.uk, and that explains everything in much more detail. And that's me.
My name is Richard Pugh, and I'm Chief Data Scientist at Mango. We're a data science company. I'm also involved in things like the R Consortium, so if you're into the R language, then I'm on the board there. And I'm also involved with Matt in the RSS data science section. And I've got the last of the three bubbles, right? I've got that business piece. So what are people asking for from a business context? When I started looking for images, I thought I'd just get some nice images in my slides. I found that if you actually Google for business and just look at the images, it's hilarious, it's brilliant. So I've included some of the, mostly it's people standing around pointing at bits of paper. There's lots of people in lines, I've noticed. But the thing I noticed was everyone's really happy. So regardless of how happy you are in your job, you will never be person in a business photo happy. And I will prove that during this presentation. This is one of the guys. Okay, so so my presentation today, I'm going to talk a little bit about my background. I'll talk about some of the impact on business that's kind of being made right now. I'll talk about something called the Data Science Radar and what it means to be a communicator, which kind of Matt touched on a bit there, and some of the skills we're being asked for. Very happy people, as you can see. There's lots of power grabs if you look online and business stuff. So my background, this is me before it all went wrong. I'm a statistician. I went to Bath University. I was very lucky in hindsight. I think it's not until you leave and you look back and you realize, wow, I was there with I had Chris Jensen teach me linear models. I had Chris Chatfield teach me applied stats, and David Draper teach me Bayesian stuff, even though it wasn't really on the syllabus and stuff. It was good. So I'm a statistician by training. I've been into software a lot, so SAS, S+, R, and so on. Involved in the R Consortium. I co-wrote the R in 24-hour book with Amy and Andy. And like I say, I'm also involved in the, that's the wrong Twitter handle, I'll show the real one, the RSS data science section. But I guess my background is I'm a statistician, but I'm a really weird statistician, or I thought I was a very odd statistician in that I always thought back in university what I would do is I would leave university, get a job as a statistician, find something in the data that saves my company or makes my company lots of money, and then get promoted. That was kind of the plan, right? And what I found is in my first job, I was very removed from the business, very removed from the decision. My job was to produce a p-value, or as Amy intimated earlier, I had a company where my first job, the biochemists, as it was then, were only really used to looking at the output from a GLM in SAS. So if I didn't give them the output from a GLM in SAS, they didn't really get what I was talking about. So literally I could walk into a presentation and do 50 slides and it would be pointless. I could walk in with one slide with just 0.001 and they'd go, all right, good. So it was a bit of an odd environment. So I was quite detached from it. I was also into coding as well, so all the things that Matt was talking about there, I was really into programming and automation and so on. So from a SAS perspective, that means I took my job, which was quite interesting, and then I turn it into a macro, and then my job becomes hitting F8 with different numbers at the top of the screen, which is really dull. So that's kind of my background, I suppose. And I co-founded Mango about 15 years ago, and that's kind of where I am now. So business impact. So what's driving this? As I mentioned there, when I was a statistician in industry, and I guess caveat here, I've worked mostly in sort of commercial world, so large companies. My job was, as a statistician, was primarily reactive. And what I mean by that is I worked in industries or companies where the role of analytics broadly was kind of like set in stone before I got there. So, oh yeah, stats is the audit department, or they're the guys who do the regulatory stuff, or the guys who facilitate this decision only. And so kind of breaking out of that was quite hard, and we were asked to do stuff, and we were providing supporting information back. That's kind of our role in that department. But what's happened since then, particularly in the last 10 years, I would say, is things like the big data movement and data science and a lot of the sort of use cases that Amy was talking about there has kind of made execs in companies realize there's money to be made around data science, right? So all of a sudden, the marketing machine kicks in and the world of analytics changes. And I'm kind of very lucky right now in that, as an example, as a statistician, I've been in the boardroom at about 10 FTSE 250 companies in the last year, advising on data science, analytics, what it can do, what it can't do, and that feels very different to me. So all of a sudden, we've kind of gone from this kind of reactive piece to a pressure for us all to be more proactive, more involved in decisions, coming up with the ideas, closer to the business. And that's driven a lot of the skills that we're being asked to somehow have now. And so now analytics as a broad topic is a very strategic aim for a lot of organizations. I'll give you one example. I worked for a FTSE 250 company who is a recruiter, so a very large recruitment firm. I was asked to come in. I was still waiting I got into the meeting, I was still thinking they're going to say, I can help you recruit, but it wasn't that. They said, I was working for the CIO, and the CIO said to me, the recruitment industry is changing dramatically, very disruptive, data all over the place, and your remit, my remit, change my business with data. That was my remit, right? And that's very different from, I have this project on this little area here that I need to know the answer to, right? So it's kind of, you're being asked now to be far more strategic in our thinking. Some of the challenges that arise, though, around this is that when I interact with a business, very often business users don't get what analytics is, what it can do, really importantly, what it can't do. I know of a firm that hired a bunch of data scientists, and the reason is because that's going to solve all their problems. And these guys internally became known casually as modelgicians, right? So this team of modelgicians, the idea being that, they're not selling enough stuff, I just bring a data scientist in, solve that. That's kind of sometimes the feeling, right? And I think that's being perpetuated by the marketing machine, right? So, a lot of the big database vendors maybe, or software vendors, or maybe some of the big consulting groups kind of realize there's money to be made around this stuff, right? So all of a sudden you kind of go, well, you hype it up, to crazy levels, right? And then all of a sudden, execs get fed with, oh, if you get data scientists in, they're just brilliant, they just solve everything. And that's a big danger, right? So that's part of the challenge. So I'm going to talk a little bit about the data science radar. These are, I promise you, if you actually go online, just type business people and hit the images, you just find all these things. The data science, so I'm going to talk about that a little bit next. So we talked about this Venn diagram, which is kind of if you boil down a lot of the definitions of data scientists, you kind of get to this, right? But actually internally at Mango, we have our own set of Venn diagrams, which looks like this. which turns into a little radar. And I'm not sure if anyone's ever heard the data science radar, but it's basically a kind of amalgamation of the skills that people tend to be asking for on job adverts and stuff like that. So you get lots of different things here, right? You get things like data wrangler, so how can you manipulate data? Is it, unstructured, structured data, and so on? Are you a really good coder like Matt? Do you use principles like data ops and so on? Are you big into technology? Do you know what Hadoop is and how it works and blah, blah, blah? Are you a modeler? Do you understand analytics? Well, is stats modeling, machine learning, OR, and so on? Are you into kind of data viz? And I suppose the last one is this, communicator, which is literally how a data scientist interacts with the business. And that's basically what I'm going to talk about in my few slides. And the reason it's really close to my heart is because my data science radar at Mango looks like this. So we each have a kind of like peer-reviewed data science radar in-house. And this is mine, right? So you can kind of see my strongest is communicator. I like talking, basically. You can see I only get like 3 out of 5 for programmer, which still hurts, I'll be honest. But I guess it allows us to define amongst ourselves who's really strong from a modeling perspective and so on. Right? So basically I'm going to talk about communication. So what skills are we talking about from the, what are the business demanding from us around, being a data science? What are these soft skills? Well, what I find I need to do these days is I seem to need to wear lots of different hats, okay? So as a data scientist, I understand analytics, I understand programming, but the hats I seem to be asked to wear kind of vary between these 5. So business, teacher, inquisitor, storyteller, and salesperson. That seems to be the hats I'm having to kind of like put on and put off when I'm interacting with the business over and over again. So I thought I'd just quickly go through some of these. Business person. So one of the big differences, or one of the opportunities that data science gives us, is we can move closer to the decision than we were before. So we're not just, in my background, like I say, very much a supporting information provider person, but actually move much, much closer to the end decision. And that kind of raises its own challenges, and the sort of skills I need to have, and the sort of things that you consider are things like, I don't know, not just, I guess, what can we do, but what's possible. Is there a financial incentive to doing this? That's part of it, right? Is it worth doing this thing? So we could all get together in this room. We could use the latest cutting-edge machine learning models, and we could tell this building, whoever owns this building, the optimal color to paint this wall, right? It's kind of white now, right? We could do a huge data science project, probably cost what, $1 million, $2 million? 3 million, right? 3 million quid. And what we'll come up with is the optimum color to paint this wall, right? The trouble is that's not going to return the investment, right? You're going to spend 3 million quid. Are you going to get the value back? Well, maybe not, right? People are going to be slightly more attentive in talks, maybe, but you're not going to get that back. And you need to be kind of thinking this through all the time when you're actually doing this work. So you end up thinking about analytics, but also thinking about, is it worth doing this in the first place? The other thing that's interesting is that we did a big project for a sort of a retailer. Oh, I flicked on, sorry. For a retailer, is I did this great bit of project. I can't tell you the customer, because you'll see why in a second, but it was all about yellow stickers. So when you go into a supermarket, sometimes there's yellow stickers on foods. They're being discounted, right? I spoke to this retailer, and they were talking about different ways data could help the business. And I said, well, these use yellow stickers. How does that work? Oh, well, the store manager just gets to a point in the day and goes, let's put yellow stickers on all the chicken sandwiches. And I go, how do they know when to do that, and how many to do it, and what percentage to drop the price by, and da-da-da? Oh, that's up to them. I was like, oh, okay. Okay, we need to do that, so we can solve that, right? So we did this great bit of analysis, and it was all about optimizing, kind of when to put the yellow stickers on, whether to put them on, which project. So actually, you're at a certain point in the day, you've had this footfall, do more, do less, and so on, right? You can you get that's an optimization problem, right? And it's a really cool bit of work. And when we actually analyzed the results of it, the results were spectacularly bad, right? Really bad. Nothing changed. And we couldn't quite work out why this piece of work hadn't really impacted. And what we found is basically what happened is every day the store manager was getting like a piece of paper saying, okay, so this is what went to yellow sticker and what and so on. And the store manager was going, you know what? I've been running this store for 20 years. So that's the problem. You also got to think a lot about the cultural impact and the change impact of doing this. If you're going to do all this really cool stuff, is the business going to react differently? Are you going to be able to track this thing? And also then about things like domain knowledge and so on becomes really important, right? So one of the things I'm being asked to be is a business person more and more as opposed to an analyst necessarily. The other thing which you see in the slide now is teacher. So I am continually asked or required to educate business people around me about what analytics can and can't do. And I think the most important bit is this bit here, the language. So we've done a lot of work recently with some customers around understanding what an analytic language looks like, right? And that doesn't mean I'm teaching people about p-values. That means I'm teaching people about, okay, what does the word model mean to a business person? How do you use it in a business sentence? How can they use it to know when to call me, right? How does the word predict, what does that mean in a business context, right? So you're having to kind of find this language that's somewhere between business and the analytic world to act as a kind of bridge, right? Because I'm never going to be able to teach a business person, a CEO or something about a p-value and a t-test and linear regression, right? They're not going to do that, right? And it's not useful anyway. But if I can talk to them about error generally, if I can get to terms like accuracy and precision and sensitivity, maybe, right? Then you can kind of find that bridge. So language becomes increasingly important. And so yeah, that ongoing kind of teaching, particularly on what's possible, right? So, someone said to me once, if you walk into a business meeting and the third word out your mouth is Bayesian, you're in the wrong meeting, right? And there's a lot of that. And so I end up trying to shy away from things like confidence intervals. I end up using a lot of simulation. So a business person won't necessarily get what a confidence interval is, but they will get, imagine tomorrow happens 1,000 times. This is the kind of range of outputs that we think we would get tomorrow, right? There's some of that is really useful. Okay. The next thing, Inquisitor. I find this really interesting. If you are a data scientist, a statistician, you're into data, and you say to someone, what's your challenge that you're trying to solve, they will give you the answer that they think you're looking for. And I've seen this over and over again, right? I was in a room once with a customer, and I said, right, what's your biggest business challenge? And I swear to you, the person said to me, we don't do enough segmentation. So what? That's not a challenge, that's a solution to... And the problem partly with this, I think, is that business people might not understand analytics, but the reason that you're in the room is because they get it's useful, and therefore probably they've read like blog posts about it. So they kind of end up knowing that you can solve problem A, problem B, and problem C with analytics, right? But then they kind of go, oh, I'll steer the conversations to those things. But what you need to do is ask more and more. So for example, I'm currently working with a company who's about to release a very big film. Nothing more. Part of the project is to predict box office take. Okay? So how do I know how much box office this company is going to get in that first weekend? Right? That's my question. And then I sit there and I go, why is that the question? And they said, what do you mean? I said, well, how are you going to behave differently? And they said, well, if we can predict what the box office is going to be, we'll know how to change our marketing spend. I said, right, so the question isn't what box office take are you going to take that first weekend. The question is, how do you optimize your marketing spend to ensure that you get the right margins from that film release? And they were like, well, yeah. But they didn't realize they could say that. They thought that, analytics is like predicting stuff. Can you predict that or this or that? Right? That's kind of that. So you end up having to ask question after question after question. And also, because you can't then say, okay, this is the model I'm going to use, here's all the assumptions, is the data normal, blah, blah, blah. You then have to use questioning to actually talk about the assumptions as well from a business context, right? So I asked a lot, and I think a lot of this, I can put a lot of this down to one module I did at university, which was, I mentioned Chris Chatfield earlier on, who was a brilliant lecturer. And he did this module at university called Applied Stats, which I loved. It was all about actually taking real-world data. You take the data, you go off, you analyze the data, and you come back and you present the results. And Chris, in one lecture, and I still remember to this day, basically failed the entire class. Everyone got an F, essentially, for this one project. And I'm sitting there going, oh, I've done this really well. We did t-tests in that class. It looked like a t-testy thing. I did this, I came back, and what's wrong with that? And essentially, the reason that he failed everyone is because no one asked him a question about the data. And I was like, and tell you what, at the time I thought, that was one of my marks, but now I look back and go, really good lesson, right? I kind of get that now. So I think that asking questions, I think we're all used to that, but it tends to be a bit more kind of having to use the language as well. Storytelling. So again, back in my first job, if I didn't show a p-value, I didn't get any anywhere really. But these days, you kind of can't do that. You have to translate what you're doing far more closely to the business impact you're talking about, and therefore storytelling around data becomes really, really important. And also it needs to fit with the cultural style of the company as well. So I'm working with companies where unless it's in a graph, people don't look at it. And you kind of have to kind of get to a point where you kind of go, okay, that's fine. But you know, that visual style becomes more and more important. There's lots of stuff online about storytelling with data, which I would talk about. And also the narrative as well. You kind of end up having to do, you know, well, this is the data, and then this is why. And then if we think about this, then we go this way, and so on. What's really good for this is some of the online replacements for PowerPoint, some of things like the JavaScript libraries like Reveal and stuff like that, if everyone's come across those, where you can kind of walk through not just like there's one slide, then the next, the next, the next, the next, but actually go, there's one slide, there's the next, then you can go off at a tangent, and those tend to be really good for that storytelling piece. And the last thing is the thing that people really rebel against the most, I suppose, which is the salesperson bit. I think understandably so, really. But it is a reality. Most senior lead chief data scientists I talk to will admit that part of their role is sales, right? And what we mean by that, and of course it's got awful connotations, right? I mean, I'm not talking that you walk around the business going, do you want to buy a Bayesian hierarchical model? You know, it's more about the fact that, you know, data science is reassuringly expensive, right? Okay, it's a big investment. It's a big risk for companies as well because they don't get analytics. Therefore, it's kind of like a bit of a leap of faith sometimes. We require some good tooling. We require decent laptops. You know, it's quite an investment for companies generally. So, of course, what they want is a return on the investment, okay? And what you'll find as a data scientist, or especially if you lead a data science team ultimately, is you tend to end up owning that ROI. You tend to end up owning that return on investment, right? So what you have to do is you have to go out into the business and find the people with the problems that are worth solving and actually interact with them and almost sell the capabilities of your team and your analytic division, which is really different from where I started, which was like the audit team that you had to have, right? So having to go out into the business, I think there was a really good presentation recently at an event where someone said the secret to good data science is coffee and cake. And I think that's a really good way of looking at it. Coffee, because you kind of, you know, you need to kind of like be in it. But cake, because you need to go and buy people cake and say, so what are you struggling with right now? Or how is that working? And try and get like POCs, or can I get a bit of your data? Or how about we try this out? And so you end up having to do that sort of like outreach piece quite a lot. Okay, so what does it all mean? So some of the skills, I suppose I'm trying to boil down some of the skills that we kind of need as data scientists. And I do urge, if people are involved in academia, I do think we need more presenting of data, more questioning, more role play, more conversational stuff around the data stuff that we're actually using, right? But the number one is definitely empathy, and Matt mentioned it earlier. You have to put yourselves in the shoes of the people you're talking to and understand what's important to them, what language they understand, what keeps them awake at night, you know, what are their aims, what are their constraints, in order to actually understand what you can do to help them, right? So empathy is the absolute biggest one. But then creativity, and that's where understanding different model types is important, because being able to actually talk about different, you know, well, we can't solve the problem from this angle, what about from this angle? That's quite an important skill to have. Having all that analytic possibility in your background. Patience, I think that's kind of, particularly if we end up talking to boards, patience is really important. I won't say any more about that. Business acumen, just understanding of the business. You know, when you actually get into a company and they say this is our mission statement and this is our credo and stuff like that. I used to have a mate who worked at Johnson & Johnson, and there was this wall in his office, and probably about the size of that pane of glass was like the credo, right? And we used to walk into his office and stand there and go, as Johnson & Johnson, and he used to hate it. But I kind of get it now. You have to kind of be a bit more in tune with that stuff now, right? So you have to get what the company goals are and so on. And then communication skills. So that's why I think presenting more and more is so important for kind of budding data scientists these days. These people are very excited that it's the end of my presentation. So I'll stop there. Actually, let me just do one more thing. So I was going to stop, and then we're going to wrap up. I've got like 2 slides left. So I'll do those slides, and then the three of us will come up. We'll have some questions, if that's all right. So just quickly wrapping up then. So you saw at the start we talked about data science skills being those 3 bubbles, right? Okay. But all the way through this talk, I think I heard one mention of the word unicorn. I think Matt said it. Okay. So when people talk about data science skills, they often talk about the word unicorn. And my daughter is not in the room, so I can say this. Unicorns don't exist, right? And they just don't. And that's true in the data science world as well, I think. So we talk about, you might leave this room going, I am in so much trouble. I've got a code like Matt. I've got a model like Amy, and I've got to do all this business stuff, and I've got a storyteller, salesperson. It's a nightmare, right? But the thing with this stuff I think is really important is that these people just literally don't exist, and I think can't exist, partly, right? So this is me, my radar, and what you can see is if I was a unicorn, right, all this would be orange, right? It'd all be filled in, but I'm obviously not, right? So I'm not a unicorn. I've been hiring data scientists now for 15 years. I've never met a unicorn. So I think the important thing is to understand that you need to have an appreciation of the different sets of skills, but actually then, and maybe like a central core, like within our team we do a lot of stuff around version control stuff, for example, from a program perspective. If you can nail that, that's kind of really good, right? But then there are people who are really good programmers, right? So I think you're looking for a core set and appreciation of the different skills, and then kind of like specialities is kind of where we are. That's what most of us feel. However, and I'm going to call this person out, there is a guy, Martin, who sits on the RSS Data Science Committee. And Matt's laughing already. He believes this is not true. So Martin gives some really good examples, to be fair, in areas like biochemistry, where people originally thought, oh, people can have that skill and that skill and that skill. That's just impossible. But now these people exist. So Martin's belief is that we all should be unicorns, and actually all those skills are essential. So I think there's a real debate to be had around this idea of, is that feasible versus it's an essential versus how we design our academic courses around this stuff, right? And what I would ask you to do is to come and join the debate. So the RSS Data Science section is a relatively new section. Matt and myself are involved. You can get involved in this debate because there is a Slack channel where we do have heated arguments about various areas of data science. Oh, it's just buzzwords, it's just marketing, it's just stats really, and so on. So do come and get involved in the debate. Also, there's a Twitter feed and there's a GitHub page with all of our information on. But this is open to anyone, right, to come and get involved, come and join the debate. And we debate about all sorts of stuff about what does good data science look like, does it even exist, what are the skills? And partly this presentation is an offshoot of one of those conversations.